want to be able to compute the net change for the displacement, simply take the integral. 1 to 4 t squared minus t minus 6 dt. I'm going to draw a graph of this. Do you know what t squared minus t minus 6 looks like? Yep, t minus 3 times t plus 2. That's my velocity function. At time equals 1 second, is the particle traveling to the right or the left? At time 1 second, is the particle traveling to the right or to the left? To the left. Why? Because the velocity is negative. At time equals 4, is the particle traveling to the right or the left? The right, because the velocity is positive. So the particle changes direction at what time? At 3 seconds. Very good. So what we're going to do is we're going to find the displacement. We simply do the integral. If you look here, I'm going from 1 to 4. Do you think I have more positive area or more negative area? More negative area. So it looks like I should be traveling probably more to the left. Well, let's figure that out. Antiderivative t squared. T3 over 3 minus t squared over 2 minus 6t. Evaluated 1 and 4. I plug in 4, and 4 cubed is, so I have 64 over 3 minus 4 squared is 16 divided by 2 is 8 minus 24. I plugged in 4. What do I do now? Plug in 1. So as I plug in 1, I get 1/3 minus 1/2 minus 6. So that's how I like to set up my integral. I'm going to do it without a calculator. 64/3 minus 1/3 is 63/3. 63 over 3 is 21. So get rid of those. I have 21 minus 8 minus 24. Looks like plus 6 and plus 1/2. 21 minus 8 is 13 minus 24, negative 11, plus 6, negative 5, negative 5 plus 1/2, negative 4.5. Yeah, Shania is the new Phantom. So we were right to consider that it looks like the object traveled more to the left than it did to the right, correct? However, if we want to be able to find the total distance traveled, that's slightly different. Distance is equal to integral a to b of the absolute value of velocity. So what you do is you take the negative area and you make it positive, and you simply add it to that positive area. That's all we have to do. Distance is the absolute value. As we said, if it was 15 feet to the door, which Logan said, and I traveled there and back, you'd say your displacement is 0, but your total distance is 30. 15 in the positive, 15 in the negative, which is a total of 30. We good? So in order to do this by hand, I must break it up into 2 integrals. The integral from 1 to, when does it change direction? At time 3. T squared minus t minus 6 dt. And then we have an integral from 3 to what? 4 of t squared minus t minus 6 dt. Is the first integral going to be positive or negative? Negative because it's below the x-axis. We'll make that positive. And we'll add it to that positive area there. I have t cubed over 3 minus t squared over 2 minus 6t. And we're going to evaluate that 3 and 1. Somebody, 3 cubed over 3. 9 minus 9 over 2 minus 18 minus 1/3 minus 1/2 minus 6. So I'm going to combine some parts here. We'll do 9 minus 18 is -9, and then will it be +6 or -6? +6. So -9 plus 6 will be a -3, so I got rid of that, that, and that. -9/2 minus a -1/2. Yeah, it would be a -4, agreed? -4. So those are gone. And then minus a third. So I have -7 minus 1/3, or -21 over 3 minus 1 over 3 is -22 over 3. So what we needed to do is we needed to take the absolute value of that. So the distance traveled in the left direction is 22 over 3. Then we're going to add that to, now I need to do this one over here. Again, we have t cubed over 3 minus t squared over 2 minus 6t. This does seem like a fair amount of work, doesn't it? The good news is that this is the most work that this type of problem will be. You're only going to have 2 problems like this on your assignment today. The rest of them, we'll figure out an easier way to do it. And the best application, how you can see how you can do it with your calculator. I plug in the 4, and we get that 64/3 minus, we already did this, didn't we? Minus what? 8 minus 24. And then I plug in 3. Hey, we already did the 3, didn't we? And we get 9 minus 9/2 minus 18. So let's go to work there. -8 minus 24. -32 plus 18. -14. So I've got rid of those. And then -9. -23. It looks like I'm going to add that to 64/3. And I'm going to add 9/2 to that. What should my common denominator be? 6. So if I multiply that by 6, -138 over 6, plus this would be 128 over 6, plus 27 over 6. What's -138 plus 128? -10. -10 plus 27. So I get 17 over 6. So it looks like the object actually traveled 22/3 in the negative direction, traveled 17 over 6 in the positive direction. And if we combine those together, we get 44 over 6 plus 17 over 6, which is in fact 61 over 6, or 10 and 1/6. Take out your calculator, and we're going to verify that. I'm going to type in x squared minus x minus 6. And I'm going to zoom standard. Does that match the graph that I drew originally? It does. So most of the work that you guys do for these type of problems, you're not going to end up doing by hand. I'm just giving you 2 short ones today to do by hand. The rest of it you'll do using tables and calculators. I calculate number 7, and this will give me the total displacement of the object, which we already said was, what do we come up with the displacement from part A? Negative 4.5. So I'm going to check 1, enter, and 4, enter. And I should come up with, did I get negative 4.5? Now watch what's really cool about this. And this is the operation that I want to teach you guys so that tomorrow it all makes a better sense. For distance, we do the absolute value. We can have nothing negative. So I'm going to insert an absolute value. I go to my catalog and I press enter on absolute value. So I do the absolute value of x squared minus x minus 6. Absolute value makes a graph positive, correct? Watch what happens to my graph as I draw. This is kind of cool. See how it takes the part that was negative and just flips it up? And so, exactly. And so now as you calculate number 7, and I roll from 1 to 4, it's going to find that, see, there it goes. So your calculator, it's tough for it to do it. Your calculator gives you an approximation. This is not 100% accurate, is it? The right answer is 10.16 repeating. It came up with an estimation, which is still pretty close, but ours is better. We're smarter than the calculator is. So there you come up with it. So anyway, good work.